Okay, so half angle identities. We have these formulas here. For sine of theta over 2, we've got one for cosine theta over 2, and we've got one for tangent theta over 2. We'll fill in those formulas first, and then we'll look at the problems to do them. So it's kind of weird because it's plus or minus with the square root. So it's plus or minus square root of 1 minus cosine over 2. And notice that whole fraction is inside the square roots. All right, let's save that conversation for another time. Okay, this one is similar for cosine, plus or minus square root. Now it's 1 plus cosine over 2. So one's 1 minus cosine, one's 1 plus cosine. I like to remember it as when there's, like, they're both cosine. So there's agreement, so it's positive, you know. A little plus sign in the middle, it's agreement between them. Whereas here they're different, so there's disagreement, it's negative. I don't know. Helps me. And then for tangents, tangent is going to be sine divided by cosine, as it always is. So it's 1 minus cosine over 1 plus cosine. Okay. There's sort of 2 types of problems that we're going to see. I think it's helpful to talk about them before we start looking at them. And along with that, there's also, I'm going to leave some space under there, 2 angles in each problem. No matter which type it is. So the 2 angles that are in each problem are theta over, theta over 2 and theta. So there's going to be a theta over 2 and a theta in each problem. Or, like, it might not be theta, right? It might be a over 2 and a, or x over 2 and x, or y over 2 and y, b over 2 and b. But we're going to be using theta over 2 and theta in all of these problems here. And so theta over 2 is, of course, half of theta, which means theta is 2 times whatever theta over 2 is, right? So there's a very direct relationship between theta over 2 and theta. The 2 types of problems that we're going to see is ones where we are given theta over 2, and the other type is when we are given theta. And you'll see what I mean. So basically, in every problem, there's 2 angles. In one type of problem, I give you one, and the other type of problem, I give you the other. In both of them, we need both to solve. So, for example, in this first one here, sine of 22.5, we are given theta over 2. And the way that we know is because if that's theta over 2, what would theta be? 45. Yeah, so I'm looking and I'm noticing, oh, that's half of 45. Whereas if I like divided it by 2, I get 11.25. That would not be very helpful. Yeah, it's because of the 0.5 and because when I multiply it by 2, I see like, oh, yep, that's 45. And I know for like 45 I'm very familiar with because it's special right triangle, it's unit circle. That would, yeah, I would not use half angle for that. In this next example down here, below the cosine formula, which angle am I given? Theta. We're given theta. Specifically, we're given cosine of theta, but I'm told all this information about theta, and then the problem is asking me to find cosine of theta over 2. So this is the other type of problem. Going back to the first one, we are trying to find sine of 22.5. So what this is really saying is find sine of theta over 2. And so that's what all of these problems are having in common. It's like find sine of theta over 2, find cosine theta over 2. We're always being asked the same thing. It's just being presented in 2 different formats. Okay, let's go to the back real quick. So this first one here, tangent of 5 pi over 8. Turn to your partner. Is that theta or theta over 2? So what do we think? Is that theta or theta over 2? What do we think? Theta over 2. Okay, how are we supposed to know? Here's a really good way to know for sure. So if it's one or the other, we can think about the possibilities. So if this angle here is theta, what would theta over 2 equal? What happens when I divide that angle by 2? 5 pi over 16, okay? Do you know the tangent of either one of those angles, or the cosine or sine of either of those angles? No, we don't. Those are not unit circle angles. So the alternate situation would be if theta over 2 is 5 pi over 8, what would theta be? What happens when I multiply that by 2? 5 pi over 4, which is 10 over 8. 5 pi over 4. Okay. We do know stuff about this, right? Hopefully. Because it's on the unit circle. 5 pi over 4 is on the unit circle. So what we need to do is look and recognize, okay, that's half of a unit circle angle. Just like 22.5 is half of a unit circle angle. Times 2. Multiply by 2. Just multiply by 2. Okay. In the next example there, are we given theta or theta over 2? Which one do we have information about? Which one? Theta, right? We're told cosine of theta, 3 over 4. Theta is in quadrant 2. We're given all this information about theta. Okay. The other way to spot the difference is notice here we're told explicitly what the angle is, and it's just find the tangent of that. So that's usually an indicator it's theta over 2. Whereas in these other ones where we're just given theta, notice it's telling me all this information about theta, and then at the very end just saying find theta over 2. But we really don't know what theta over 2 is because we're given stuff about theta. Okay, so with that logic, numbers 1 and 2 are asking about which one? Theta over 2 or theta? Theta over 2. Yeah. I'm asking directly about these angles. I'm not given any other information about some other angle. I'm just told find cosine 75. Well, 75 is half of 150, which is on the unit circle. Pi over 12 is half of what? Pi over 6, which is a unit circle. Number 3 is a different, is a proof box. Okay. So, because my process for solving those is going to be a little bit different. So let's go back to the first example. No matter what, my first step is to answer this question: what quadrant is theta over 2 in? And so this is going to determine the plus or minus part of the equation, which we notice is out front of every single one of these. So we actually have to decide if it's positive or negative. Okay, so for our first question here, theta over 2 is 22.5. What quadrant is theta over 2 in? First quadrant. First quadrant is less than 90 degrees. Okay. I'm looking for sine of a first quadrant angle. Sine is what in the first quadrant? Positive or negative? Positive. Everything's positive in the first quadrant. So, when we do our formula, it's not plus or minus now. Now it's just positive. It's going to be 1 minus cosine theta over 2 using the formula. And so what's theta again in this problem? 45. So it's 1 minus cosine 45. What's cosine 45? Root 2 over 2. Okay, so now I need to simplify this. I need to find a common denominator, which is going to be 2. And this is taking me right back to the warm-up. So this would become 2 over 2. This would become 4 over 2. And I'm canceling out all the 2's. And then notice we have a big square root for square rooting a fraction, which means we square root the top and bottom. We can do it separately. What's the square root of the bottom equal? 2. So our final answer here is with just a square root on top. And with 2 on the bottom. Yeah, we are going to leave the square root inside the square root up top. It's a little weird looking, but you know, some of you guys are weird looking too, so I don't complain. Mikey.
Where did you get the 4 from?
The 4, on the bottom, I changed the 2 to become 4/2 to have a common denominator. Other questions on that one? Okay, let's look at the next one. So the next one, again, looking at it, we're told that cosine of theta is 8/17. Theta is in quadrant 4. Find cosine of theta over 2. So we're told all this information about theta. Oops, that's not quadrant 4. But we're trying to find cosine of theta over 2. So we need to answer the question, what quadrant is theta over 2 in? Turn to your partner. What quadrant is theta over 2 in? Yes, quadrant 2. Who's got a better reason than just quadrant 4 divided by 2 is 2? Mikey?
Because if you take an angle in quadrant 4 and divide that by 2, then you go to quadrant 2.
Yes, you're exactly right. All of these angles in quadrant 4 are between 270 and 360 degrees, just by default, right, because of where they're placed. If I divide any of those angles by 2, any single one, I could pick 300 degrees, I could pick 270, I could pick 360. 270 divided by 2 is what?
135.
135. So that's the smallest possible angle that we could have. And 360 divided by 2 is? 180. So any angle between 270 and 360 that's divided by 2 is going to be between 135 and 180. So like 300 degrees divided by 2 is 150. There we go. Great. Much faster. So 150 is in there. Right. So all of those fourth quadrant angles, when you divide them by 2, are in here. They just have to be in there. No matter what they are. So again, we're told information about theta. We're using that now to help us find theta over 2, because what we're ultimately looking for is cosine of theta over 2. So we're looking for cosine of theta over 2. Theta over 2 is in the second quadrant. Cosine of an angle in the second quadrant is positive or negative? Negative. Cosine is negative in quadrant 2. So when I use the formula, it's going to look like this. Cosine theta over 2 equals negative 1 plus cosine theta over 2. And what's cosine of theta? 8/17. Yeah, that's what we were given. Ah. Okay. So same process here. I'm going to get a common denominator. But any questions on how we got here? At this point, we've done all the thinking. Now it's just simplifying, which you still need to think for, but it's not like It's just following this. So common denominator is going to be 17. So that bottom's going to become 34 over 17. Cross off my 17s. Keep that negative sign out front. It's not allowed to go inside the square root. So I get negative square root of 25 over 34. Can I simplify that anymore? Is that square root of 25 exactly? So square root of 25 is 5. I still need the negative sign. So this becomes negative 5 root 34 over 34 when I rationalize. So everything in the blue is basically just simplifying the answer that we first got from the formula. So that's like algebra 1, algebra 2 type. It's not super easy, but everything in red is like the pre-calc part, the trig part. Questions on either part? Questions on any part of this problem here?
Yes.
Color coded for convenience. Okay. So to recap, two types of problems. Here we're being asked about theta over 2. We need to figure out what theta was, and that's the one that gets used in the formula. Should be a unit circle angle. Second problem, we were given information about theta, and then we were being asked about theta over 2. We had to figure out what quadrant theta over 2 is, and that's a little bit harder to do. Let's go to the back. So, example 1 on the back here. Tangent 5 pi array. Again, we were told, we figured out that we're given theta over 2 because theta would then equal 5 pi over 4. I want you guys to set up this equation, and then I'll go around and check it, including the positive or negative, so you got to figure that part out too. Just set up the equation. Okay. So, first of all, remember our question is, what quadrants is theta over 2? Second quadrant. Theta over 2 is in the second quadrant. Okay, so remember, this is the angle that we care about, not this one. We care about theta over 2. On the unit circle, pi over 2 is right there at the top. What would that be in eighths? Yeah, that would be 4 pi over 8. Which means 5 pi over 8 is just a little bit to the left of that. And of course, like pi would be 8 pi over 8. So it's in quadrant 2. And then, for theta over 2, what are we looking for? Sine, cosine, or tangent? We're looking for tangents. So in quadrant 2, tangent is negative. Okay. So make sure you're following that thought process there. The angle we're looking for, 5 pi array, is in the second quadrant. We're looking for the tangent. Tangent in second quadrant is negative. That's why we have a negative out front. There's other logic that can get a negative out front. That's the one we want to make sure we follow. Okay, so then we're doing 1 minus cosine theta over 1 plus cosine theta. What's cosine theta? What does that equal? root 2 over 2, negative root 2 over 2, right? Cosine 5 pi over 4, negative root 2 over 2. So it's 1 minus negative root 2 over 2, 1 plus negative root 2 over 2. We're going to find yield common denominator, make those 2 over 2's. Okay, so again, similar to last class and the class before, we are fine with this answer here in regular pre-calc. If you're planning on taking AB next year or thinking about taking AB next year, you want to go ahead and rationalize that, which you would do by multiplying by the conjugates, 2 plus root 2 on the top and bottom of that fraction, and simplify from there. Oops, 2 plus root 2. And it eventually simplifies to this, right? Is that what it was? Yeah, so it eventually simplifies to that, which is nicer, but we can stop here. We're taking AB next year, go ahead and take it all the way to this. We're thinking about it. Questions? Okay, I see a lot of you guys are making some progress on the next example, so keep doing that one. We'll check in a sec. Okay, let's check. What quadrant is theta over 2 in? 1, quadrant 1. Quadrant 1, because theta is in quadrant 2, meaning it's between 180 and 90. So theta over 2 would be between what two numbers? 45 and 90. Yes. Okay. So in quadrant 1, tangent is positive. Okay. So tangent theta over 2 is positive. 1 minus cosine, 1 plus cosine. What's cosine of theta equal? Yeah. So I'm doing 1 minus negative 3/5 over 1 plus negative 3/5. Change those to 5s over 5s. So I have 5 plus 3 over 5 minus 3. 8 divided by 2 is 4. Square 4 is 2. Questions? Okay. I want to look at this proof, and then that'll be it. So I'll leave those other examples. We want to do this for practice. Okay, so proofs with half angles. Similar to some of these other ones, what we would want to notice is that the variables are different. So we would want to just expand this side because it's using our half angle identity. So it's kind of similar to the ones we saw in the homework, right? Like the variables don't match. Use one of those identities. Our half angle identity is plus or minus square root of 1 minus cosine theta over 2. So that's our left side. And then there's a fun little twist that because it's squared, it's sine squared of theta over 2, it would be all of this squared. So what is squaring it going to do? Right, it's going to get rid of the square root, and it's also going to get rid of the plus or minus, because if you square something, it's always positive. So this just becomes 1 minus cosine over 2. See, that is a fun twist. It's just straight facts. Like,
Would it still have the plus and minus?
no, because if you square, it's always positive. Okay. Now, as I'm noticing, I've got something pretty simple on the left side. I've got something that kind of looks like it on the right side. Left side I have cosines. Right side I have secants. So why don't I just change those secants into 1 over cosines? Oops. Any ideas on what I could do now? Tim? Change the 1 on the right to cosine over cosine. Yeah, so we're common denominator, and then cancel them out, and then I'm left with 1 minus cosine over 2. Whoa.
Oh.
Oh.
Well, that's crazy.
Hello? Stop. The way to do this only on one side is I would divide the top and bottom by cosine, which would make it 1 over cosine minus cosine over cosine divided by 2 over cosine. Or you can multiply by like secant over secant would be another way. Yeah. That's probably how I would do it, is multiply by secant over secant. So that becomes secant minus 1 over 2 secant. Nice. Nice.